Welcome to the first Academy session of the 2023-2024 season. For our audience, the Formula Bharat Academy Series are complimentary sessions with industry experts, which are available to view at any time on your YouTube channel. The subject of today's session is Formula Student to Formula One with Jagadeesh Padrachalam. A little bit about Jagadeesh. He graduated from Oxford Brookes University with a master's degree in Motorsport Engineering, and he was also a member of Oxford Brookes Racing. As a member of the team, Jagadeesh was responsible for tyre modeling and simulation of vehicle performance. In his current position, he is involved with Formula One as a Vehicle Performance Analyst. An overview of the session. To give you an overview of the session, there will be a run-through of Jagadeesh's career and road to F1, what you should expect from the industry, career path in motorsport and opportunities, area of affinity, vehicle dynamics and simulation, and then followed by a Q&A session with Jagadeesh. Some general instructions to our participants on Zoom. Please mute your microphone throughout the session unless you are asked otherwise. We would encourage you to turn on your audio and video during the Q&A to make this an interactive session. So without further ado, let's begin the session. Over to you, Jagadeesh.
Hello, good evening, everyone, and thank you for joining today. I hope I don't eat into too much of your weekend already. So let's start with a quick introduction of me. I did my bachelor's in mechanical, graduated in 2018, and then started working for LMW. If anyone is into CNC machinery, you might know who LMW is. And then I moved on to MRF as an industrial engineer, and I was there for around 3.5 years. The main reason which I wanted to move to MRF was to save money for my higher studies. So yeah, and then once I had enough funds to pursue my masters, and I moved over to UK to do my masters in motorsports engineering, because that was the only way which was possible to get into the motorsport industry if you are not from a tier 1 or tier 2 university. So yeah, it was a 1-year course and it was quite hectic as well. So you need to take care of your academics, participate in Formula Student, and then manage if you're going to a part-time job, that as well. So in the end, it is a good, worthy reward, I would say. And currently, I now work as a Vehicle Performance Analyst in Formula One management. And if you would have seen F1 TV, you would have seen the onboard graphics such as cornering analysis, vehicle performance strategy, insights provided by AWS. So we provide that info to the graphics and a lot of load of internal analysis as well. So a brief insight on what we do. There is a 3-tier of work level during a race weekend. So it is pre-event, live, and one is during the post-event. On each of these 3 categories of events, we do an internal analysis and an external analysis. The internal analysis, as you say, would be confidential. The external goes to the TV presenters, editors, and the graphics teams. So they could provide you with a better worth of information on deeper insights, technical insights that happens behind the scenes of a race weekend. So this is the example of plots which we use to send. 1 second, I'll share my screen. So this is the example of plots which we used to send to the TV guys, graphics, and external media people. And this is the example of last event, Bahrain Grand Prix. And you would have seen this kind of graphic highlighted by Pirelli in a much nicer way to the public. The expected pit stop and strategy windows. We give this information to the graphics team who then modify it to a much more presentable way and an understandable way to the public. And you would have seen a lot of teams did not use medium compound tires during the race. And if you see the tire offset and tire degradation plot on the left, you would see there is not a lot of time delta between the medium and the hard compound tire, and not a whole lot of time lost between the medium and the hard compound tire. So that's why, to eke out more laps, most teams preferred for the hard compound tire rather than going for a medium and have to pit a little early. And this is on the right corner bottom, you would see the expected stop laps, and most of the teams have pitted in our expected strategy windows, with an exception of Red Bull and Alex Albon. Red Bull this year have clearly improved their degradation over last year, which they weren't the best, but still they did a better job this year. And we would look into some of the post-race analysis, like what if Ferrari did not go for the hard tire in place of a medium, which they often tend to do. In the grand scheme of things, it looks a bit a content for a social media, but when you do a deeper analysis, you might see certain chassis or certain cars work better in one particular compound of tire. So it is, in the end, it is the responsibility of the team who must analyze their car's strength and weaknesses and pace difference to choose optimal strategy for their drivers. So it is kind of hard when you consider the pressures involved during a live event, and it is quite easy to get wrong. So we analyze, like, what if Leclerc was in a proper race tire that he should have been, whether he would be able to challenge Verstappen for the lead, etc. And that bit you see in the Palmer's analysis on F1 TV if you have like a post-race debrief of what happened. And this year, a new addition to the F1 TV or the F1 Unlocked, you might see an ex-strategist, Bernie Collins of Aston Martin Formula 1 team. She has started to write more deeper technical insights on how race strategy works, like a strategy unlocked. Let's call it that. So we provide a much more detailed analysis on that, and followed by her write-up, it goes into the web. You could have seen, if you are an F1 Insight subscriber, you would have seen that already. So this is a brief thing of what we do. Of course, this is for an external, and there is a lot of internal analysis that which we do, which goes out to our internal clients like Pat Simmons, Craig Wilson, and Pirelli. We work closely with Pirelli to understand tire life and tire degradation, such that we can come up with good strategy decisions and, let's say, an accurate strategy for the weekend. This is just a brief insight of what I do here, and let's talk about how the team structure of an F1 team comprises of in general. So you will see, let's put it into three. You will always have an admin department, a logistics or make it happen department, and finally your R&D department. So that is the three core departments, and which is then split into HR, finance, marketing, such that. And depending upon the scale of the teams, let's say if you take a team such as Haas and a team such as Mercedes, you would see a stark difference in amount of people they have, which you might have probably seen in the Drive to Survive. So this is just a simple approximated numbers of how the amount of personnel varies between a small and a large team. And let's say if you want a specific role in a team, the best place would the best place where you would possibly want to look into is 100% I would recommend LinkedIn, because a lot of team leaders now post their job requirements directly before it goes into their careers portal, and finally motorsportjobs.com website. So these are the three uh, places where I would look for the job role. And what are the positions available inside? So you start as an intern. Let's say if you are doing a 2 years integrated course, master's course, and you could have a break of a month or two to do your internship at a particular team if they have a vacancy there, and you will go back to studies once you complete that internship, which is uh, most common here. And then an apprenticeship. So at the end of completion of your studies or towards the end, many teams will open up a post for apprenticeship. This is more in line with the requirements of UK government, same as what we have in India as well, to train students on that field, so that they open up a posting for apprenticeship, where you will be given a contract for 1 year and possibly extended more if your performance or your level of performance is good. And the third one is a default one, which most of us would be willing to join into, which is like a more permanent graduate role. And the graduate role openings differs between team to team. Some of the lower midfield and the teams which are much lower on the constructor standings do not have that many openings around, but you might see one or two floating around. The majority of the graduate roles comes from top teams. They have many openings, which closely agrees with the team makeup numbers which we see here in the screen. Okay, now we have seen how many members each team or particular team has, what are the places to look for to get to know about the job roles, and what are the roles available. Now we will go into more of the selection process on how it happens. So for an internship, you will be mostly interviewed by the HR first, and then a group leader. The group leader will be the head of department of whatever the posting you are being applied for. And the second one is apprenticeship, same. And the major difference arises when you move higher up. So for graduate engineer, you will be first going through the HR, which is basically a technical test. If you pass through it, you will go to your group leader or who will be managing you directly. And then once he is satisfied, if required, the head of the department might interview you, but this depends upon team's discretion. Some teams do it, some don't. And direct roles, you will have again the same 2 rounds, which involves group leader and head of department, and finally followed by the HR, since you already have some years worth of experience, so you will be directly passed on to the group leader and head of department, and then finally HR to let's say, a basic expectation of pay as such. And let's move on to general insights. I wouldn't call it necessarily for vehicle dynamics, but let's keep it neutral here. So I was attending as a virtual judge for the engineering design review this year for Formula Bharat, and I did see quite a same level of what to say team performance as we have here in Formula One as well. That is the team with a low, medium, and a high budget category. So each team can exceed and perform above expectations if you have a realistic goal set on what you need to do in a competition. So let's say there is a requirement of where people will ask you to set a department goal for your team or your individual department, and you will be setting up some expectations which might not be possible to uh, be achieved by your team, whether it might be in terms of knowledge you have or mainly because of funds, lack of funds. So I would recommend the teams with such difficulties to more or less understand what your team's capability is first, and then move on to setting your department goals. In that way, everyone has a fair share of ideas put together, and which will then help you to build a better team base or a better baseline for your car. So that will be always my what to say recommendation to any of the teams here which are struggling to get funds or partnerships, let's say that. And whatever you do, always remember that how good the idea may be, if you are not able to uh, what to say, if you are not able to proceed your ideas in this year's car due to one of the reasons which I mentioned earlier, don't try to force it, because your next car will always be your best car. So document it, whatever your idea may be, and it's up to your peers to decide whether it is a valid idea or they can build upon. So whatever you do, whatever methodologies you adopt, do a detailed write down, debrief after the event or after each task, and prepare a good documentation so that others don't have to start that from the scratch. So we'll see what each team category needs to do based upon their budget. So let's say if you are a team with a low budget, use as much as old parts as possible as permitted by the rules. Of course, there are some parts which you cannot reuse from a year on year concept. So apart from that, use as much as old parts as possible, and do give importance to basic validation studies. Let's say uh, if you are using some old parts, you could save up some fund to buy an IMU, let's say inertia measurement unit, or two of the linear potential meters, which you can then perform a basic vehicle dynamics study by doing a straight line test or a constant radius test to understand lateral and longitudinal load transfer. So once you have gotten a real-time data, you can then use Lotus or MSc Adams to check whether your virtual model is correlating with your real-time model, so that you have a strong case of validation. Let's say you can use that during your engineering design review to say, yeah, you did some validation, and that will be more helpful to me. Let's say you are a team with low budget and you manage to do some form of validation with a real-time vehicle data. So that will put more, that will learn more points than having an idea or having a good concept but no validation at all. And if you're a team with, let's say, an average budget, I would recommend focusing on improvements. Let's say if your previous car had a simple coil spring suspension, then I would go into more into adjustable dampers and studying about that and making smaller improvements such as this, an example which I said earlier. And then try to collaborate with more industries. So let's take the same example of going into adjustable dampers. If you don't have a damper dyno in a university, you can then collaborate with external partners or organizations for them to able to test your dyno, test your damper in their dyno and give you the test results. Most probably, if you are going for an adjustable damper, the manufacturer will give you the uh, what to say, the spec sheet and all the curves for each setting. But yeah, I've put that as an example uh, in a short. So yeah, there might be some other things such as your FVM analysis or non-destructive testing of your uprights as such. Let's say an example of that. And if you are a team with high budget, let's say you have all the bells and whistles to do, you develop your own arrow, you have the capability to develop a carbon fiber arrow parts, then I would consider you as a high budget team. Then what I would be looking forward from such a team is a more advanced kind of concepts such as, yeah, what you see, traction control and torque vectoring. If you look at the FSG teams and their quality of vehicles, you might see more teams have incorporated torque vectoring 5 years ago, I believe. I'm not sure, but they have been doing it for a long. So I would expect the same from a high budget or a top team in Formula Bharat as such. And then I would uh, focus more on virtual simulations, since currently that is the trend here, which is followed in motorsports, by reducing, as you see in the amount of track testing time has been reduced this year, and the emphasis on doing more virtual simulations has been increased to improve cash flow between teams as a cost saving measure. So I would recommend you developing some same methodologies while correlating the same virtual performance with the real time data whenever you do track testing, etc. And then the final part, which is common for all of the teams, is create a basic version of lap time simulators to see how your concept will perform in a real time track if you are about to run your vehicle. So I've seen only very few teams give more importance to that this year, but I would recommend all the teams to have a, a lap time simulator as such, because you can then clearly define your vehicle concepts based on that. Like if you're focusing on either more on low speed cornering, or I suppose Formula Student has more of low speed and medium speed corners, but you will be able to choose between whether you want arrow for that or you don't want arrow. You might see where I'm going with this. So I would recommend you to develop such tools which will enable you to, what to say, have an idea of your vehicle goals or where you want to go with it. So I would recommend you with that. And for the teams which have more people and budget, I would go further into a simplified driver in loop simulator. If you know the software called Cruden, that seamlessly links with Simulink, which you can use your vehicle model that you develop for your lap time simulator, and you can then expand it to a virtual track or a virtual scenario where you can use your basic home simulator kits such as your Logitech steering wheel, and then you can create a driver in loop simulator. You can then present that as your a simple a simplified concept which many teams even in UK doesn't do. So that will be a good step or a good achievement for the team. As far as I remember, in Assetto Corsa, you do have Monash MC17 car and an FSUK track. So they have managed to do that. And it would be nice to see if you could replicate that as well. And what are the advantage of doing that? So each team here in Formula One also has a driver in loop simulator, which kind of functions the same way as a game engine, and then they get or extract all the data from the simulator, and then they correlate with the real-time vehicle, and they see the differences between those and correlate them and further improve their vehicle model based on that. So by doing this, you are kind of following the same trend which happens in Formula One too. So that would be a good step up, I would say, for the teams which already have a good budget and more people. So this doesn't happen entirely in a year. It takes years of building. That's why I say your next car will be always your best car. It might take time. You might not be able to see it, but this is how a development path should be for each of the teams which are in their respective categories. As an alumni, if you are about to leave or graduate a university, I would highly recommend you to stick around, help as much as possible, because the only way the current team has an easy access to the industry is through the alumni. So it is your duty to stick around and help your team to achieve these goals. And a simplified version of lap time simulator, what it contains. So for any lap time simulation, you need a track, a tire model, and a good vehicle model. If you don't have the inertia measurement unit of the track, you will find a lot of GPS points available where you can then use SolidWorks to draw a racing line. And then you will get a track file, which you can then use it for your MATLAB in whenever you are estimating the lap time. Or if you are a team with an inertia measurement unit, you can then use the output signals of that unit to create a driver model, a replica driver, not a replica, it is a real-time driver model which who drives around the track in real time. So you will get an accurate track file data. And you only need three outputs from that, which is lateral acceleration, your speed, and time. With those three inputs, you can easily create a racing line code. I think there is a lot of literature in internet to do this, and you will get a proper good racing line, which is from a real driver, a real-time human driving the car. So that will be more accurate and help towards your lap time estimation. And the second subsystem is the most important thing, which is tires. And this is the section which normally teams try to avoid and use the pre-existing, or let's say a basic default set of values which we find on the internet, but that shouldn't be the case. There are lots of online resources which is available to uh, help you in this regard. If you go into FSAE forums, you will see a lot of people asking questions, right from the basic set of questions to a more advanced level. And you might see this name Bill Cobb more frequently answering all those questions. So you don't have any excuse to escape from this. Uh, let's say you have all the tools you need. So develop a basic tyre model which where you can extract fx, fy, and aligning moments for different vertical load and pressures. So based on that, you will get a, a friction ellipse of each of the tyre parameters that we introduced, that is for different vertical load or a pressure settings. You will get fx and fy for each, which you must then use as a limit for your acceleration surfaces, or what we call it as limit acceleration surfaces, because you will be always either limited by power or grip. And in most probably for a Formula student car, you will be limited by power, but in case if you are, let's say if you have an electric powertrain of 80 kilowatt with four-wheel drive, you will break traction easily, and in that case you are most probably limited by grip rather than power. For in order to know when are you breaking your traction, you need to have a good tyre model, which will then you have the ability to get your friction ellipse or your tyre limits as such, which you can then feed it to your vehicle model and then create a lap time code to estimate what will be your estimated lap time around a lap. And here is where the torque vectoring and the traction control comes into play. So having a good tyre model will also directly influence the success that you have in your torque vectoring and traction control systems if you have in your car. And let's say if you want to create a good vehicle model, this is a basic version that I did for my master's thesis here. So you will know the vehicle velocity based on the powertrain you select, and from that you will calculate the aerodynamic forces if you have any installed on your car for entire velocity range. And from that aerodynamic forces, you will then add your vehicle weight distribution to those aerodynamic forces, and you will get the range of fz for your entire vehicle velocity range. And you can use that fz to have a basic uh, magic formula function, let's say 5.2. 5.2 is a good start. You will get fz, fy, and mz, which then you can use to find your ggv of your vehicle model. ggv is nothing but your lateral, longitudinal, and speed. In this case, I would recommend you to use yaw rather than speed. Why I am focusing more on using yaw rather than speed is you can then have an idea of, let's say you are using a component of 5 kilos heavier for 1 year, and you are using a component which is less than 5 kilos the next year. And if you want to see excuse me, how much it affects your vehicle performance overall, you need to have a yaw inertia sensitivity in your vehicle model to pick up that difference. So I would recommend you to develop a GGV based on yaw rather than a velocity. And so if you are creating a basic version of lap time simulator, you will have a track file which consists of apexes spread across the distance. How do you identify apexes? These red dots, as you see from the image on the right hand side top, these red dots are apexes. And the apexes is the place where your yaw acceleration becomes zero, which means if you're inducing steering, your yaw increases to a certain limit, and then it goes constant, and then it turns into an opposite sign once you are steering out of the corner or as such. So those points where your yaw tends to zero is your apexes. So if you identify those points around the track, you will then need to find your acceleration and braking zones. So from the apex, you will start accelerating, and before going into the apex, you will start braking. So based on the fx and fy limit available from the tires, you need to find ax and ay from those apexes. You need to write a program to find ax and ay from those apexes. And when you link all those apexes together, you will find the velocity trace as you see from this diagram, uh, bottom right. You will get a velocity trace, and from that velocity trace with respect to time, you will get the overall lap time, basic lap time estimate. So in this, the traces on the green is from the real car, and the traces from the red is the simulated one. The vehicle model that I had did not have any aero sensitivity towards pitch, and there was no suspension model. It was just a basic vehicle model and a tire model. So you will see a lot of miscorrelation between the simulated and the actual car. So this isn't very hard. You have already many resources that on the YouTube as well to do such kind of analysis. Let's say, for example, Jonathan Vogel, Michael from YouTube Open Lab, I guess. So they both have documented a well, a better vehicle model and a lap time simulator than what I managed to do. So, and it is open for all and free for all to use. So I would recommend you to start using that as a baseline and then develop your advanced concepts so that you could have a similar one of that, let's say. So this is what I wanted to share my views on today about more on what I do and what I recommend from having seen the engineering design review on this year's Formula student class. So if you have any questions, we'll go into that.
Um, Jagdish, I guess Trijal Kumar has a question. He has raised his hand.
Mhm.
Trijal, you may go ahead.
Hello, good evening.
Yeah, good
Actually,
evening.
I'm in my class 12th right now. I'm just going to pass out this month.
Mhm.
And I just wanted to know, how do you get into Formula Bharat? Like, how do you participate over there? Like, from which universities do you join there? Like, are there
Uh,
any specific universities or?
there isn't any specific universities to, let's say, excels in one part of the thing. It's more
Okay.
upon what you can afford, which university you can afford, and picking the best one out of it. That is what matters
So,
most.
like, if I join a university, let's say I join MIT,
Hmm.
MIT Manipal, and I
Hmm.
select mechanical engineering over there. So,
Hmm.
like, it depends on universities, right? Like some universities take part in Formula Bharat, some universities don't. So do we
Some,
have to look at?
yes, yeah, you need
So
to pick the best one which you can afford to join.
okay,
That is the
depending on
first thing, and then
whether
yeah,
do they participate or not.
yeah.
Okay, okay. And one more thing, can you
Hmm.
reach F1 from India only? Like gaining
Currently,
experience
they
in India.
have, yeah, I think it's possible. Currently, they have relaxed visa rules,
Okay.
like a new global talent visa or something, but I haven't looked much into it. Let's say if you are doing all of the things which I have mentioned briefly now,
Hmm.
you will have a better shot of
Uh,
reaching F1 directly rather than
l-
having to do an MSc here.
Okay, so we can do masters from India as well and gain experience over here.
Yeah.
Because there are multiple teams in Formula Middle East, I believe, who are participating from India, and there are
Mhm.
even Formula Bharat teams. So that's how you can
Yeah.
do it. Okay.
Yeah.
Okay. Thank you so much.
Cheers.
If I may add on to that, Jagdish, do you mind if I also add to responding to his question?
Sorry, I couldn't hear you.
Yeah. Do you mind if I just add on to the question about how do you get into participating in Formula Bharat? Do you mind if I take that?
Yep. Sure. Sure. Sure.
Yes. So, Chajal, just to mention that you can either join an existing team, and if the university doesn't have a team as such, you can definitely think about starting one. So,
Okay.
yeah, you can always start one. So, it's the students also have to look into starting their starting a team or something. So, we always
Hmm.
promote new teams even coming up. So not
Okay.
necessarily join a university that already has it. You can also go elsewhere, see if there are people who want to start a team, and you can always start one. And we
Okay.
always run initiatives that promote teams that want to start either building EV team or something. So you can always participate in that.
Got it, ma'am. Thank you.
All right, thank you. Yash, you can go ahead with your question.
Good evening. I was hoping like if you could talk a little bit about how you got accepted into Oxford Brookes and your experience there.
I think Oxford Brookes accepts nearly 200 students annually on average from India. So, uh, getting into Oxford Brookes wasn't that hard of a deal. I don't know if it is the case for everyone else, but on my part, it was quite straightforward, right from the process of application to getting accepted. So, I wouldn't say it is much of an issue. And what was your second part of the question?
I was
Is it
hoping like if you could share about your experience at Oxford Brookes. Like what would an average day in your life look like?
so? You will have 3 days worth of lectures per week, and remainder of the 3 days you will be either doing the coursework, or in my case, I was more involved in Formula Student. So on those 3 days, you will be focusing fully on the Formula Student team, and they do have quite a lot of alumni who work in other F1 teams who give industry insights and methodologies for us to learn about and develop our car based on that. And plus, the university also has a 4-post rig and a damper dyno, which you can do all the KNC tests upon. And we also have our own DAL simulator as well. And yeah, have we had a quite bit of tools already uh, to learn upon and develop ourselves, which do help the students a lot. So that's why I strongly emphasized on having the industry partnerships of such organizations that do a similar kind of work in India, so that you could replicate the same there as well.
And what other universities did you apply to?
Uh, with the budget I had, I did choose only one university, Oxford Brookes. I didn't look into other universities as any particular or such.
Thanks a lot.
Looks like no more questions as of now. So thank you all once again for joining in. And a big thank you to Jagdish for taking this session. It was really insightful, and I thoroughly enjoyed it, and I'm sure that everyone else did. Uh, to all the participants, if you all have any questions, either now or later, you all can always write to us, and we'll surely make it a point to forward it to Jagdish, and he will get in touch with you all. Um, I do see a raised hand. So I think that'll be our last question for today's session, and then we will close the session. So I did not know the name of the person because it's just highlighted as an iPhone. So whoever it is, you can speak.
Hello, sir. So I was thinking of doing which masters would you recommend so that it would be an easy place meant to get into an F1 team.
I will be quite frank here. An F1 team has a lot of job roles which requires a specialization in different categories. So as a basics, with whatever passion you have in mind for any particular subject, I would say you will still find something to do in F1. And I would emphasize more on how you learn and what you learn when if at all when you are applying for such master's courses, such that your skill set will make your application so strong that you can't be denied by during an interview process. So I would give more importance to that more over the course, let's say selection of course. So if you have a passion towards mechanical design or something, you could choose a course which strongly emphasizes or specializes on that, and you will have a lot of roles in F1 such as designing peripherals for the engine, AeroCAD, tooling for your chassis manufacturing as such. So you will always find something to do in F1 regardless of what course you study. It is same as the industries which operate outside of F1. So you are good to go with whatever the choice you have.
So if I am interested in mechanical designing thing, so would you recommend me to take a master's in that or do a master's in motorsports?
So the reason why I want to do motorsports is I hadn't had the chance to study aerodynamics or vehicle dynamics much into detail. Yes, I was in MRF, which helped a lot with understanding the manufacturing process involved in tyre and all its composition, blah blah blah. And I simply couldn't connect how that works in tandem with a vehicle. So whenever I applied for the job roles, I didn't get through. So that's when I realized I need to focus more on connecting those dots together. So that is the reason why I applied for motorsports. So if you are interested in mechanical design, I would strongly recommend you to do a course which aligns more with your career choice. Motorsports is just a general overview of connecting those dots if you have some knowledge already what to do.
All right, sir. Thank you.
Once again, thanks everyone for joining in. Have a great evening. And Jagdeesh, once again, from my end and from the entire Formula Bharat team, thank you so much for hosting this session. It's always a pleasure working with you, and hopefully we can have another one soon.
Yep, sure.
Thank you.